have to show you a book which I have here because I'm not where I'm sitting normally. If you give me a minute, I may have to search it out.
Okay. So, yeah, like Christian pointed out, unfortunately, I didn't record presentation. He said it was excellent, but I will briefly just go over some of the details right now, and next week I'll present some more because I don't want to disappoint. Totally without any recording. I had everything set today, so I'll just briefly go through in 5 minutes. Unfortunately, we didn't record. I had about a half an hour presentation. Both Laszlo and Christian, thank you. Thanks to them. They were listening very carefully and they said it was a great presentation. But I hope to present it again. Probably I record it and put it, or next week I can present it.
You could probably also record it offline without us as a presenter and then cut it into the video by Christopher so that that part which is not live is taken out and we come to the same effect then. That shouldn't hinder us in taking the questions, for example. It's just for the audience who's looking at the text is unfortunate that they cannot see the tense. You have to, of course, redo the presentation then next time.
Yeah, I don't know how I missed that, but anyway.
Yeah, that can happen.
It happens. Can happen.
If you give me a chance to ask you not a question, but show you one of a material which you should know with respect to exactly all of the 10 or 15 pages you showed right now, especially the parts of relativity were intriguing because many people know the original papers of Einstein and not all of the very specific material you had there from your personal experience of calculating numerical aspects of relativity. I want to give you now a book. This is a German book, but don't let be held off by being a German. I'm not sure if that book has been translated. It's from Birkhäuser Verlag. It's a very small verlag, and it's called Relativitätstheorie, so theory of relativity. And if you give me the full screen, the people might have a look on the cover of that book. The author was Louis C. Epstein. And I'm not sure if that is visible. If I can keep it here into the camera, you would probably make me full screen to make it readable in a size for the audience to see. Yeah, that is better enough. So this is the book. It's mirrored, I think, at the moment because I can't handle it the camera the other way around with the current presentation software. But this is how it looks with a train and a piece of paper.
Wow.
And is called, I translate in real time because the backside is also German, a jewel around of the books on theory of relativity. So what makes this book so special? It has about 240 pages, but it has a lot of very, very interesting graphical illustrations in there from page to page, which are quite untypical. So these are more the typical ones, which could also be seen in your presentation. But in the end, it's doing something which is outright spectacular. So I never seen something ingeniously clever like that. So what you can see on this page, I can only explain what it means. This is the way how I learned relativity without a single equation. Or is it how does that work? How can you learn relativity? And I'm not talking about special relativity. This is something for pupils in the 10th grade. This you learn at school. And believe it or believe it not, I don't believe special relativity, but that is another thing. It has to do with ice-space theory, why I'm pretty sure that special relativity is missing a crucial point, namely the Doppler effect. But that is something for history of physics discussions beyond my loan level, I put it this way. So professor level need to discuss that detail out historically, what happened there at the conference, in Solvay conference when they nailed it. No, what this book is talking about, RT, about common relativity, so that what you presented right now. And what this book is able is to explain with, call it a time trick, the quantitative, experimental, verifiable consequences of common relativity without doing a single equation. But in the end of the book, there is something which is, make a photocopy of that thing, make an A3 copier, do a very large sheet of paper, copy that page, take a scissor and cut it out. Yeah? Then you see the geometric effects of theory of relativity with a piece of paper and a scissor in 3 dimensions, as elements you glue together and can make a picture of. And you might think, oh, a nice model, a good didactic way of this Louis C. Epstein, but no, he has made a final page. This is actually an addendum to the book. It's called Appendix A, how to add up speeds properly. This is a nice picture of Albert, by the way. This is a really rarely seen of him. And
will you be able to, during your talk, can you briefly, like 5 to 10 minutes, demonstrate that?
I will refer to that book because relativity and theory
like
of ice has basically nothing to do with each other at first sight, but it has everything to do once you go to the more than 4 dimensions, which you need for. I don't need the 10 dimensions for mathematical reasons. The string theory needs the 10 dimensions for mathematical reason in its theory, or it doesn't work. Christopher, you know best. The ice-based theory needs actually just 3 dimensions, but when you play with Lego in 3 dimensions, it wouldn't work because we see no Lego around in our world, so something hidden must be going on. And when you hide something from the 3 dimension, it must be very small. And these small spaces are typically called in current mainstream physics Calabi-Yau spaces. They are well-known, well-researched objects you can look up, and they are folded together in a way in all books, which is, I have no other word for it, completely wrong. And that is illustrative what they show, but it's bullshit. Because when you have a Calabi-Yau space and you fold it in the way the Calabi-Yau space mathematically inclines, you're doing exactly what I say to do in ice space. You glue the left side of a box to the right side. You glue the top side of a box to the bottom side. You glue the front side to the back side, and you cannot do that in 3 dimensions because after 2 times having done that in X and Y direction, you need to glue the inside of a torus to the outside of the torus, and that is definitely not possible in 3 dimensions. And unless you are inclining that God prefers the x-axis or the creator or whatever is your person on thinking of that, I don't think it prefers the x-axis, so you please do that symmetrically. So x is glued to not to minus x, but to x dash or anti-x. And epsilon is not glued to minus epsilon, but epsilon dash or anti-epsilon. And z is not glued to minus z, but anti-z and anti-x in the sense that anti-x and x, anti-epsilon, epsilon, anti-z and z are 90-degree vertical upright on spatial dimensions, and that you end up with a 6-dimensional thing. And suddenly I can do Lego movements in 6 dimensions. The problem is now inside the box, everything is Lego, and quantum mechanics works perfectly in that Lego box of ice space and gives all the constants of nature's ice space theory is able to calculate. So that works perfectly. The question is, where is it? And it took me 20 years to find the answer where it is. Standard quantum mechanics tells us, and relativity tells us, that everything is a continuum-style point particle. And if you talk to a more experienced physicist, and I've talked to plenty of them, actually, because I had luck to meet them in my life, in person. Some were my teachers, even in my hobby of ice-space physics. I'm not an expert at all, but I can really ask nasty questions to expert people. And when you ask a nasty question to expert people, they don't brush you away. If you get brushed away by a nasty question, then the person you're talking to has already stated he is not an expert. Otherwise, he would think about your question and not brush you away. True experts, including non-experts, don't brush you away when you ask a clever question. They hold in itself and say, wait, that is clever. I have to think about it. I cannot answer it right now. Call me in a week. I think about it. Or whatever they will tell you, but they will not say, what a nonsense, next question. Yeah? And this is what I really, really learned. And from a top 10 of the best people in the world, including people at Wolfram, but not only there. And that means when you ask them, how can it be that the electron is a point particle and has an extended field? In a collider, the point particles would never meet, because would they be really infinitely thin, they would fly by and never touch each other, so their field is extended. So you cannot say, not mathematically, but also not physically, that an electron has a 0 size. And when I was talking to the, let's say, more inclined, clever, experienced 50-year-older plus persons, they said, Christian, of course the electron is not a point particle. Now I was stunned. I was sitting there and said, hey, you're teaching me quantum mechanics, And I asked you 5 minutes before, is the electron a point particle or not? And you said it is a point particle. And I was learned in school, point particles have 0 size. And then it dawned on him that we were speaking like bridge builders, like I coming from here and he coming from there. A point particle means that it is so small that it is typically unmeasurable. And that is the definition of how a person, a human, a brain, has nothing to do with physics, defines a point. So when a mathematician defines a point, it has 0 size at the center of a circle, which has a radius of 2 pi r with a normal Euclidean pi. And when I do circles in I-space, we don't have that. We have suddenly a Euclidean, non-Euclidic geometry, Lego style, where you get strange integer numbers for your circular number like 4, 6, 3, or even a fractal one. That is just I-space theoretic stuff we don't need to discuss now. But this is not God-given. This is not creator-given. It is what you define. And what the mainstream has defined is what you learn in school. Unless when they meant otherwise and forget to mention. So what happens, everybody tell us we have Heisenberg uncertainty in everything, right? It's everywhere. You cannot measure exact position and velocity, energy and time, or whatever combination of 2 parallel aspects which exclude each other. And they tell you in every book that would be impossible. And not by measurement precision, but by principle. And now the tricky thing back to the electron. The electron is indeed a point particle, but when it is a 6-dimensional Calabi-Yau space, then it is not the picture of this wobbly-wibbly thing which they show you in all string theoretic books. And I mean, really, all I have seen, no exception, there might be others, I cannot read all books, but all the ones I have looked at show me that wibbly-wobbly 6-dimensional thing in a knot style combination of plane graphic mathematics, actually. And that is wrong in a lot of ways, because this is not plain mathematics, it's not a line mathematics folded up like a curl of a cat playing with some wool. Yeah? This is totally different. When you have a Möbius band and you make it 2-dimensional and fold it 180 degrees, you have a single surface per design. There is no up and down anymore when you do that simple geometric operation. But what you did, the horizontal plane of your Möbius band paper, which you folded 180 degrees before gluing, became a 3-dimensional object. You cannot make it flat anymore. It is folded. So a 3-dimensional object, Möbius band, is a 2-dimensional surface. No, it's a 2-dimensional surface which is endless. This is infinite. It doesn't change the side anymore. You will come back out where you come back in when you follow it with a little car driving on that Möbius band. Now, when you make that 3-dimensional, you have for each dimension x, epsilon, and z such a Möbius band, which naturally gives you 6. But that gives a crazy thing which most people, even the expert, cannot see or understand. You now get an object which is having only inside, but no outside anymore. So the object has all the mass, had all the energy stored, all the standing waves, everything you do inside the box. It could be even our whole universe. Could be inside that box. We wouldn't notice, and it's big enough. But per definition of the glued together Möbius band logic, we have no outside anymore. And now we step a couple of meters back and look from a meter's distance to that point. If you have only inside and no outside anymore, how small is the object? Oh, wait, a point particle. And this is exactly what we measure in accelerators. So there is no critical objection to against these measurements. They see exactly what happens, but that is a guaranteed point for I-space theory and string theory. It is guaranteed not 4-dimensional. Because even if a simple electron is already 6-dimensional, embedded a 3-dimensional plus time 10-dimensional overall space, just like string theory predicts for purely mathematical reasons. I-space predicts the exact same for logical reasons, because you cannot play with Lego in a continuum world. You would see that. And as it is not the case, the Lego is hidden somewhere. And when you hide the Lego in some 6-dimensional Möbius band box, the box has not the Calabi-Yau optics in the box. The box becomes a minimized point with all the mass, all its entities, what it is representing, like spin, energy, movement, vectors, everything is still there. From the field point of view, outside of that point, but it's invisible. You cannot see it because an object without outside is invisible by definition, like a black hole. It's gone. Not even light will be making it visible when you point to it. And I think that is intriguing. This is just, call it an analogy for the moment. But why is that so important? Because this book, this Relativity from Louis T. Epstein, had a similar metaphor. What I told you is just a text metaphor. It's not math. It's not, you would have to trust my words to make logical sense and think a weekend over it before you tell anything to that. I took a long time to think on that point particle thing. And I'm pretty sure this is the solution to the problem from both ends. Relativity is correct when you have 6-dimensional Calabi-Yau spaces, and ice-based theory is correct that you have Lego. There is no contradiction. This is the important point to say. And in the theory with Gerd, who has a 4-dimensional theory with a modified Big Bang time setup, to put it this way, and ice-based theory, which is strict Lego in all aspects, you would think that can never be made compatible. But we had the same Mathematica calculations inserted into each other. So we inserted the ice-based theory into his full calculation, and everything came out more precise. So it was converging. It was not diverging. And hence, they are fully compatible, the models. And that was very surprising. And this is what the world needs to get to know. They should stop fighting on each other, not the QED expert people should tell, these conferences on string theory is a waste of money. Don't do that because there are no 10 dimensions, blah, blah. And the people searching for 10 dimensions probably don't believe in their own quantum theory because they're searching for supersymmetric particles, which they will never find because there is no supersymmetry. Now, for 20 years, energy blown into the CERN accelerator with zero result, zero result. Yeah? So how much energy and how much accelerators you want to build until you build a completely new model, a new theory, something which replaces Einstein and quantum mechanics altogether. And it will not be ice-based theory. It will not be Gerd's theory. It will be the understanding that all these theories are not wrong. They are just compatible in a way which no one imagined, okay? And people much more clever than us and next generations will have to work that out in new books which start from scratch with a single attitude different to the current books, that it is a possible way. There's a chance to solve it. And you cannot solve anything when you from the beginning exclude that there ever will be a solution. So for 100 years, I read in every book and in every discussion, constants of nature cannot be calculated. Yeah, boys and girls and everyone, it can be calculated because I did it, okay? So it was a myth that it cannot be calculated just because the best people in the world had no idea how to do that. And I came up with simple multiplication and it worked. So sometimes it helps to step back and remove all the complicated mathematics and think on what could be the core. What is the super easiest thing down there geometrically? And that works. And that is exactly what this Epstein book from relativity theory does. And he talks about a myth. And that myth is that we are never at rest. If you think for a moment, we would move with speed of light in the direction of time. In a 4-dimensional world, if you are in X, Y, and Z position at rest, where my finger is, the finger is still moving through time as the video counts its frames with every frame, right? So it doesn't move the X, Y, or Z position, but it moves frame by frame through time because there are not a single frame, even if I don't talk. There will be frames on the video which shows you that the finger was in the same X, Y, and Z position, but the video advanced. This is what I mean with we move in time direction. And if you now make just an illustrative purpose, which is very, very good explained in that book, and in no other book I have seen that, just even as an example, as a cross-reference, as a link, nothing. Epstein is the only one. And the book is from wait a moment, to make that clear how old that is. I read that when I was young, so that is very old, actually. Where is the books? Here, printed in Germany, 1985. It's 1985. Okay. So I think old enough to be overlooked, typically, okay? They have 2 generations of physicists not knowing this book because A, it was written in Germany, and probably even if it is not written in Germany but in English and has been translated, then it is forgotten by history because seemingly not interested because no equations in that book. But the book is telling you how relativity works without equation. And that should be interesting for everyone, especially for those not inclined with mathematics like me. So I'm good in mathematics in the sense that I have Mathematica on my desk and I can ask any question to OpenAI that can in turn ask Mathematica AI that asks a proper question. And I get a graphics which I have never imagined without knowing even what I'm doing there. With the modern Mathematica version, 2 years ago, without the AI, that would not have worked. So I'm not saying that you shouldn't know what you do, but today's methods should become more and more human intuitive to ask the right question than to in-depth know the math of something. The math is not irrelevant. The math is just work. And if you pretend to be clever because you're good in math, what shall I say? History will forgive me. You know nothing, okay? Go back, read some good books and come back to do the actual physics, the actual geometry, the actual, not the math is nothing. The math is a screwdriver, okay? To understand something, you need to disassemble the things and the math will guide your thinking. But the physics is not following your math. The math is please following the physics, okay? And this is very important. Very important. When you make a model, it is just that, a model. Also, iSpace, while very successful at constant of nature, which cannot be accidental, is just a model. It doesn't guarantee that there are 6-dimensional Lego blocks. All it guarantees is that it would be very unusual if there wouldn't be 6 dimensions when you have that crazy results and give that 12-digit precise, experimentally verifiable answers in a theoretical prediction. It is just, if you win in the lottery every weekend, it is too unlikely to be wrong. From one point, yeah? And most people, who are they who do theory of relativity? They have studied 7 years of physics, then they become a doctorate degree, another 5 to 6 years. Then they're working they have not worked in a single real world project. They were theoretically in the brain filled with theoretical stuff, math and even more math, but they haven't done anything for the world. They have just produced input into their brain. And at one point, forgive me, an old professor dies, and a new one, a doctorate degree, becomes a new professor, and suddenly he has to teach beyond the research. And how much he trained in his 20 years before? Nothing. He has just learned math to understand the physics he wanted to study. He is not having a single real-world project with companies like Apple, Intel, Google, you name it, on IT. He has just been theoretical all the time. And this is the thing. In IT, if we are theoretical, we are out. We have to write practical apps, practical programs, which are as bug-free, as secure as possible. We cannot just draw back and say, hey, if we research 50 years, we have a theoretically bug-free program, but you have to wait a little bit. So no one will allow that anymore. But in science, in physics, this seemingly is still allowed. We do 20 or to 30 to 40 years of string theoretical research with zero result, and don't question if there would be better ways of doing that. Not because of the money. The money is well invested. All I'm saying is, not everyone is an Edward Witten who can intuitively visualize 11 dimensions. I pretend to be able to visualize 6 and 7 dimensions of Lego because that is comparatively easy. But a string theoretical 10-dimensional thing where every thing is a wave in 10 true dimensions, not just partially spatial on each other, no one can visualize. This is just math. You see the equation, you have to follow them, what they tell you. But you don't learn anything with that. You get only, as you said, numerical results. And that's a problem. And with the book of relativity here of Epstein, and that brings me to my concluding words. I'm sorry that I did such a deviation, but it has here attachment B, a different view on relativity. And that different view ends with a mathematical proof, which looks like this. This is the upper graphics here, which you see. This is a 3-dimensional diagram where, and the x-axis is the relativistic projection, on the y-axis is the books geometrical paper and scissor relativistic correction, with the single attention of time is flowing in the time direction as a physical movement, which normal relativity doesn't tell, of course. So when you think for a moment that time is not bending space, but time is flowing like an x direction with speed of light, everything at still stand would move with speed of light through the direction of time. And suddenly 4-dimensional time makes sense. But then the mathematical equations of relativity should not go the root of x squared plus y squared plus z squared minus t squared plus times c squared. It should go root of x squared plus y squared plus z squared plus tc squared. And the time would be a true direction like any other direction and be not subtracted. And when you're not subtracted, all this nonsense with bending space is suddenly gone away because it's just a direction. You get the point? This is probably too much. You would read half the book. But what it says, this mathematical proof which I showed you, shows.
So we cannot use Minkowski space-time. We cannot use Minkowski space-time.
I don't say you cannot move. You get correct results if you do, but you have a horrifyingly complex mathematical apparatus to get to that result. And you have no logical explanation why geometrically that should be correct. It works when you measure and verify experimentally. Then the particle in the collider is exactly there with the mass it should be, and everything looks correct. But this book proves mathematically that you don't need all of that apparatus. All you need is an idea, and that idea is what if. And the what if experiment, Einstein was very good in, is that what if we are in an elevator and so on. This is what if thinkings are the best questions you can ask if you don't brush them away. And I didn't brush the relativity book away when I read it when I was age 18 or so. This is really old. Yeah? And I didn't understand it either fully because I was far from having these mathematical apparatus what Mathematica can handle today. And I wasn't even thinking because physics wasn't my hobby at that time. But I had it in the back all the time. Yeah? And all my decisions on iSpace results were influenced by these kind of books I read when I was age 16 to age 25, because you cannot get it out of your head. They are there, implied. Yeah? And your decision cannot remember why you think things are correct or why you think everything is Lego. This is absurd at first time, but it's not absurd when you aggregate all your knowledge together. And most people don't have the time in their day jobs to read enough books, to aggregate enough knowledge of contemporary physics and high-end current physics, because you don't have the time to read all these papers. I have seen the best people at Wolfram Research 24/7 in their day job reading papers, and more papers because they wanted to keep up with progress. And as long as the internet was not invented, well, that worked. And with the invention of the internet and YouTube and bidirectional everybody, me too, is a physicist, including hobby mode people like me, you cannot read anything anymore because reading any paper on ResearchGate is nigh to impossible, even if you started at day one like I did. It is too much. You miss things. So who tells you as a physicist, as an expert, as a human being that you read all the papers you needed for doing your job in your whole life? Well, I tell you, when I put it from a scientific point with purely IT background, I started with the soldering iron at age 16 and soldered my first computers when you couldn't buy some. And then I read everything, bought everything, programmed everything from any CPU on any operating system over everything which was available over the last 50 years. Because I'm crazy. Okay, I was interested. IT was my hobby. So I was not just doing my work. I was doing everything because I could. In my spare time, no girlfriend, all these kind of things. Works. At least sort of. A given time when you're crazy enough. But after a certain point, Microsoft delivered software to connect to the internet, and people wrote own operating systems. Other theories came up, other operating CPUs came up, open source CPUs came up. And no, I don't have read all that. I know that it exists, but I would not have the ability to go in depth beyond the MIPS CPU, for example. They're literally stopped. So all these modern open source CPUs today, I'm not aware of. I know that they are there, but I don't know enough. And when some of these guys would have a new caching schema which would outpace Intel's or Apple's M logic, nobody would notice because all these high-end experts were only talking about Apple CPUs and Intel CPUs, and that's it about because they have already too much to do to read these papers. And is the question now that you cannot know everything? No. What I try to tell in the audience now, hopefully recorded, is don't become ever silent in the sense you have read enough and don't need more information in your brain. Learning is an endless process. You never stop. And we in IT know that much more than most people who haven't studied math. You study 5 years math, you make your doctor degree, you might even become a professor 2 years later if you're an overflyer. And then what? Oh my God, you learn so much. Your salary is $14,000 a month. Why should I do anything else? Now let's get a comfortable life and catch up with all the, I want a wife, I want 2 children, I want a house, I want a car, my house, my auto, my boat, my vacation. And suddenly you have no time anymore to read these papers. And then you miss a lot because time isn't in standstill. It goes on without you. And people working at certain companies like Apple know that more than others because the day job there has typically 16 to 18 hours and no free vacation day, 365 days in a year. And then for 5 years until they finally get a very long vacation when the product is done, namely. But not all companies are crazy like that. And this is just an example, okay? But I know from first-hand information that it is working that way. And would people now in research work with the passion we do here at Tax, the progress would be much higher. But they become older and lazier, and hence all the math they learned when they were young, they stop. They want not new math. They think once mastered quantum mechanics, once mastered relativity, we mastered everything. It cannot be more complicated. I know everything I need to know. And then some new moron like me comes with an integer multiplication quantized theory and said, I can calculate constants of nature by multiplying. Now, of course, these people think I'm crazy and that cannot work because they know all the math and didn't find any idea how to do that because they thought so much of the math and not enough about the physics how to do that. I searched 20 years on how to do that and no math. I guess where's the advantage? I'm not more productive than anyone else. I'm not more clever than anyone else. Not at all. I just did the right thing. I focused on the problem and not on the solutions. And the theory is not that you make a TOE, a so-called theory of everything, and then become a Nobel. This is like baking a cake and eating it before it is done, okay? You bake the cake, and no, you bake 10,000 cakes, and one of that is good by chance, and that is hard work, and not an accident. And someone maybe become knowledgeable of your cake, tastes that cake and said, wow, that is a cake I've never eaten before. We should do more of this cake. And then a theory might slowly become the next mainstream because it is tasting well and people like tasting well things. And nobody, trust me, nobody likes the mathematics of relativity, and surely nobody, including Feynman, likes the theory of quantum mechanics where you renormalization-wise cancel out into sums your infinities, which shouldn't be there in the first place. I mean, it cannot be more wrong, okay? A theory as wrong as quantum mechanics need to be just trashed and rewritten. But it has never been done because as wrong as the theory is, it gives results. It produces us computer chips where we can communicate in text conferences on high-end Macs and PCs. And because it has been so successful, now, if it is successful to violate the core mathematical geometric rules that you have a Taylor series with plus and minus and you can cancel out of sums, okay, then maybe the teachers in school should tell the children at third degree that it's not so difficult to cancel out of sums when they give them a bad a note from their exam when they beginners mistake-wise do these things. Yeah, so young students cancel out of sums because they overlook the plus sign and think it's a time sign and cancel it off because then the equation is easy to solve. And of course, it's as wrong as could be. X plus 1 over x is x plus 1 over x and not 1. And that's it. Yeah. So and if you do that in an infinite series or not, you cannot cancel your x. And if your x goes to infinity, you search for a new theory and not for a reason why you are allowed to cancel x. And all of mainstream for 50 years since Feynman is now canceling x out of sums and said, oh, it's okay. We know it's wrong, but it works so well. I said, come on. If you're on the wrong track in a completely wrong direction, would you please at least recognize that? Even if something works well, it doesn't mean it is even close to correct. This is nonsense. And when you read the Feynman books, I've read them in English, all three. All four, actually, and there's thousands of pages. I read them in English and I read them in German. I read them 4 times to be sure I really understand at least 10% of what's in there. And Feynman himself said to everybody, this is a lousy trick. Don't do that. We just have no better method. And that correct sentence from Feynman is transformed into current mainstream physics, telling us, do as much as quantum mechanics, more is better. Oh, really? Yeah. So when one wrong division by 0 is bad, then we do thousandths division of 0 by a supercomputer, then it's much more effective. Yeah, come on. Is that mathematics? I tell you what that is. In my world, in IT, this is bullshit, and you get fired if you do that. And that's it. Because you're obviously unable to do proper programming. When you have constant exceptions in your Java program, I fire you. Because we don't catch exceptions, we program no mistakes in the program in the first place. How about that? So the same logic we can learn from IT is not to hide the mistake under exception coverings and tell, why do you complain, Christian, the app never crashes in reality? But the app crashes for 50 times a minute, we just don't see it. Yeah. Oh, clever exception. Yeah. So this is exactly the same. You must not allow to study a theory which misguides you for the rest of your life because it works so well. And Feynman knew that. Feynman knew that. And this is all I want to say, because there are better alternatives. And I'm not about ice-based theory, like these books of relativity, which I showed you here from Louis C. Epstein, which I hope is also in English available. I have to do a research on that. I don't know. That was 20 years now in my bookshelf. I was just covering it up because I think a link in your paper should be added from that book, because it clearly shows that there are alternatives which are truly simple. In a world time is a epsilon direction and time is flowing into time, and you want to explain why a particle doesn't be able to get older in a certain mathematically constrained way, then is a super simple thing. When you have x and y axis, this is your time direction here, and this is your x direction, and you get a circle here, a normal circle. So the equation for that quarter circle is x squared plus y squared is z squared. You take the root, so you have the standard equation of the circle. And when you now assume that your y direction is not a spatial dimension, but a time dimension, then a crazy simple thing happens. The faster you go into the x direction, the less time you have to go into the time direction. So when you go with near speed of light, you have already an angle of near 0 degrees, and there is no time able to spend for the time direction, because all your time is spent in the direction of x already, with that simple metaphor. And I'm not sure if I make myself clear here, but it's really that simple, of course, for x, y, z direction at the same time. And that means, with that simple metaphor, that we are objects which move through a time direction physically, we can build the same, exact same verified biomathematical proof in this book of Louis C. Epstein, without having all the mathematical apparatus of the last 100 years built up, which just misguide us. No, they don't misguide us. They make supercomputers busy. And all you need is a paper and a scissor and a little brain to think about what you're actually doing there. And maybe I'm oversimplifying, but I thought I oversimplify with ice-based theory as well 20 years ago. And as of today, I'm pretty sure I'm not. It was exactly the right direction. And things become Occam style simple once you are going in the right direction. The more you go in the right direction, the more things come to you and say, hey, this works and this works and this works. Why is everything working? And the answer is because you at least are not going constantly in the wrong direction. If you're going constantly in the wrong direction, when your goal is in the north and you walk to the north and you come at a point where north is visible, then you shouldn't wonder why that was a good idea. You walked in the right direction. Or when you're constantly going to the south and said, where are the hills? Where's the snow? Where's the North Pole? And you end up in a sunny water bay area. It's like you shouldn't wonder, because you walked in the wrong direction. Will not come. Yeah, you need to walk around the whole earth and come back from the wrong side, and then you maybe do it. But it's a shit lot of more work. So why would one with a sane mind want to do that? This is just, you need to upfront think more before you use the toolkit of mathematics to apply zero-dimensional mathematics in the sense of Euclidean point, Euclidean line, zero width, Euclidean plane, zero height, to everything. You cannot apply that to everything. So you're not just making a four-dimensional theory by taking 3 dimensions and adding a 4th dimension. Mathematically, you can do, but this is not physics, because everything in physics has a height of 1 in minimum. So when an ice-based mass falls into a black hole, it doesn't end up at 0 being spaghettized into the black hole. It ends up at height 1. And height 1 is the smallest universe height which the universe has to offer in whatever unit system you choose. If you choose iSpace, you get pixels. If you not choose iSpace, you get something else. But what I guarantee you is you don't get 0. And in theory of relativity, you get 0. And that is nonsense. This doesn't mean the theory of relativity is nonsense. It means that applying certain mathematics till infinity is nonsense, even in relativity. And of course, in quantum mechanics, where you get infinite number of virtual particles, just to tell, this is interesting, by the way. I have an equation in iSpace, which I could show in a different text, which shows that you can calculate this golden ratio divided by 2 times 3 times 6961. That gives the quantum Hall resistance in volt over ampere in an exact way. And I'm pretty sure that is physics, but this is a finite expression. Golden ratio is finite. If you make it, for example, if you don't like golden ratio, then you do the Fibonacci of golden ratio. But latest, then you have a ratio of arbitrary digit size. You divide it by 2 times pi 3 times 6961 and get a finite answer of arbitrary precision. And this is not an approximation. This is an exact result. And when you then think a moment and step back, say, what did we do there at the moment? We had assumed that circles are pi 3, that they're hexagonal circles and all this kind of thing. And that leads away from the original problem. If you want a solution which would be accepted by mainstream, it would have to have an integral sign in the front, or it would have a differentiation symbol in the front, and not just some multiplication and say, this is much easier than you thought. They don't believe you because it's too easy for them, literally too easy. So I was thinking, is it possible to make an alternative equation in which case I can show that I have an infinite sum and get the exact same finite result? And I managed to do that. And it means that I can have a sum with infinite number of entities which accounts to arbitrary number of digits to exactly the same result in golden ratio by 2 times 3 times 6 times 6 ones. And when you look in what is summed up there, that is really interesting. Namely, there is golden ratio contained, but not pi. And golden ratio in iSpace theory is a charge, a naked charge without mass. Charges are always without mass, but that means suddenly in the sum equation with the plus signs, infinite number of times, every plus sign has minimum of 1 golden ratio in it. And this is what quantum mechanics sees in their virtual particles. These are virtual charges which they see in the mathematics, but it doesn't mean that these virtual charges are physically there. Because when you calculate with iSpace mechanics, you only have 1 true golden ratio charge, and that is the real one. And when you calculate with quantum mechanics, you have these infinite terms which have to cancel out, because the infinite mechanics comes from the usability of E function and sinus cosinus functions. And when you integrate sinus cosinus over the E function, you get infinities. So your method of solving the math trapped you in your own blocking infinities. And the finite part of quantum mechanics, for example, as far as I know, in the condensator experiments with the force distance when the condensator plates become too small together, is -12 times something. Yeah? And this -12 is the finite part of this integration when you cancel out the infinities. And this interesting part is 12 is a number which is iSpace compatible, because this is 2 times 2 times 3 times 1. And this is 12. This is showing that actually the finite part is Lego. So what quantum mechanics calculates is iSpace theory, just by not knowing that they have to be in the wrong geometry. 4-dimensional geometry is the worst geometry you can do to do constants of nature calculations. And with that, everything of quantum mechanics. It works well if you have a supercomputer, but it makes no sense because it's a deviation. When you work in polar coordinates, you sometimes solve certain problems very easy. When you work in 3-dimensional coordinates, you get a lot of complicated equations for the 3-dimensional parts, x, y, and z, which you may not be able to mathematically even solve or just approximate numerically. So the choice of wrong coordinate system kills your idea of being solvable or not. And this is what Feynman meant in his book when he said, don't do that, it's just a trick. And instead of believing the inventor of Feynman diagrams integration equations, because these integration equations are directly one-to-one proportional created from the Feynman diagrams. And that should make you think, how many of these diagrams can you nest in a sequence and to what order? And the current order is, I believe, 9, even 8 or 9. And there is trillions of equations in a supercomputer to get to 9 to 10 digits of precision. And that is crazy, because in iSpace I get to the exact same precision by doing multiplication of 4 quanta. Now choose what you want to learn at school. So I know the answer of that, believe me. And I know what people and school pupils, especially when they are young, before they are poisoned with all that infinity and zero math from Hilbert. This is the worst one. So Hilbert formalized the one, and others who are now in the Hall of Fame of mathematics are very prominent. I would say they should be banned from the books, because they polluted the whole decade, not a decade, no, a whole century of science with nonsense mathematics, which should be just Lego style, simple multiplication of base quanta. And you cannot make an accusation to these people, because their measurement results at the time were 5 to 6 digits after the comma, and everything was welcome, which just fit the experimental results, and they had to do all the understanding. And they did well. Bohr did well, Heisenberg did well, Schrödinger did well, every of these genius people did well. What problem happened is, from the 50s, exactly what you call contemporary physics, Rajan, that to today, that is the problem, that people is the second generation after these historic titans, which suddenly just applied the knowledge of them without truly understanding it or creating own knowledge to get to or adding something to the world. So when you learn all that relativity books of available there, I think you still know nothing, because the mathematics will not guide you in the right direction. You're running to the south, trying to get to the North Pole, and that works. While it is utterly necessarily uncomplicated, just go in the different direction, and it's only a couple of miles away. While you have to run around whole of Earth, literally over the equator to the wrong direction, and you think, wow, we need to build ships and boats. We need to have warm houses where we are over the South Pole. So a lot of complications just because you took the wrong starting direction. And I'm honest, seriously thinking this is the problem of current science, because mathematics in its core form, with integration and differentiation theory invented by Newton, at least for Gauss came later. So is the core of the problems we have today. If everything is quantized, you need summation and not integration. If everything is quantized, then integration is the real theory, the real physics, and summation is the integration is the approximation. And sometimes it's a really good approximation, nothing against that. But you must never forget that it's just that, an approximation and not the truth. And especially when you go to the borders of integration borders, the 0 and the infinity, and sometimes the box integration from 2 to 5 maybe, or from minus pi to pi, whatever you do there, you assume 0 with borders. And the iSpace theory tells you even your borders are not 0 with. Your borders have a minimum of 1 pixel. And I can see that in the iSpace mass equation for the electron. The electron has 111 symmetric pixels. That would be a beautiful result. Unfortunately, it's wrong. It's completely wrong, giving completely wrong result if I use that. But when I add a border pixel left and a border pixel right, according to iSpace geometric theory, I get a value of 111,113, and suddenly electron mass splits out. And that is not accidental. That is geometry. But it's children's geometry by playing with Lego, literally Lego. And probably people should pay more attention to discrete methods than they have been done in the last 100 years. Discrete methods are not numerical approximation with supercomputers. Discrete methods start with the core geometry in your brain, which you try to model by believing everything is discrete at heart. And if you then cannot see that discrete, that the reason is accepted, but this is just a fake method by the universe cleverly hiding anything in these Calabi-Yau integer spaces where no outside exists, and hence a point particle is having not any width or any mechanical size you can define it. Not even Planck length. This is not a Planck length. 0 is 0. It's not Planck length. And you must never work with 0, and you must never work with infinity. And when I take the 0 away from you, the infinity is automatically away. So ice-based mathematics says we start counting at 1. So how do you count your fingers? I count my fingers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Only C programmers do that. And they get crashes with pointer errors and arithmetic errors all the time because they do so. Proper children, proper human count from 1 to 10, like on the phone. The 0 on the phone is not a 0. The 0 on the phone is a 10, my dear friends. Because a relay clicked 1 time for the 1, 5 times for the 5, and 10 times for the so-called 0, because it was no space in the hole for the fingers. There is 10 on the phone, not 0. 0 is just in mathematician's brain. And infinity is the unavoidable consequential error of inventing the 0. And invention of 0 is the unavoidable error by selling something you don't have. Because when you have, say, some 5 books on the shelf, and you get an order for 6 books, and you are lazy and said, I sell that 6 books, even if I have only 5, you need the 0 to go to -1 books in your records. And you buy that 1 book later, and then you send 6 books. But for the logical second, until you have the 6th book which you can send, you had -1 books. And now I tell you a truth. Don't sell things you don't own. If you don't sell things you don't own, you don't need a 0, because you don't have -1 books. You can also not eat -1 apples. It's not possible. And this is the thing where every problem comes from. Remove the 0, automatically remove infinity, start counting with integers, and get a life, get a woman, get children, and raise the children, play with Lego, and suddenly things become much, much easier to understand for everyone, really. Much, much easier. But that's what I wanted to tell, basically. Sorry for the long excursion, but I think I have a point there, because I think the universe isn't complex. It is complex in a sense that there are a lot of things to learn for a lot of topics, let alone politics or whatever we have currently in the press. But there are more interesting things than politics. And after the dust has settled, the interesting questions will come back to us, like what is sustained energy? What is life in 10,000 years? Will Earth survive? All these kind of interesting questions can be discussed in philosophy, but philosophy is often running without mathematics. Philosophy is running with human brain and thinking, and allowing the thoughts not to get killed because it is not written in mainstream books. There is no wrong or right in philosophy. There's just an opinion in philosophy. And you cannot prove philosophy, but mathematics you can prove, and easily, actually. And the physicists take all the mathematical things to prove that their physical ideas are right, but that is wrong, because all they prove is that the mathematical tool they're choosing is not completely wrong, but good enough to give an answer at all. And that doesn't mean it's right. It's just not completely wrong. And that is something different. So you cannot ever prove that a theory is correct. You can only falsify theories. So you think of a thing which a theory predicts and says, I make an experiment and see if that works. And if it's not coming out, it's not immediately a proof that your idea has been wrong. You make 10,000 experiments, maybe you falsify it in the future. But one single guaranteed falsified predicted effect, and the whole theory is gone. Because when the theory says we don't ever have the sun coming up in east, and you look out of the window and you're sure the sun come up from east, all theories who say the sun rises in the west are out. That's simple, yeah, because everybody can see they rise at east, and that's it. And if you have a heliocentric world image, which ended the Middle Ages in mainly German area with the clerical split-offs of evangelical church and Catholic church at that time, those who were looking in a telescope win over those who were just thinking they can pray what was written in books, whatever good these books have been in the past. Yeah? So you can believe in whatever you want. You can believe in string theory or in math or in something, but there is something which I would call an observable, realistic fact every day in life. And together with some human stomach understanding, without having run through a complex professorial degree or anything, everybody can make its own conclusions about the world and its things. And it's not that complicated, actually. It's really not that complicated. And the less mathematics we put into these things, but more good questions, which are then philosophically and practically discussed, maybe also by politicians, we really bring the world forward. This whole theorizing of following a fake idea of being able to create a TOE and then become very prominent and solve up Einstein and everybody else will be fixing everything else later with this theory is just nuts. It's nonsense. Because these theories of Newton and the theories of Einstein were not completely wrong either. They were just incomplete. And incomplete theories are not wrong theories. They were just ending at a border which they created themselves. And Einstein's theories are not wrong. They end up at the border when you look into a border of a black hole where you can calculate anymore what is behind that Schwarzschild horizon, because it will not tell you. It is by definition mathematically impossible to tell you what happens when you get spaghettized at the dot, because nobody knows. The equations themselves don't tell you. They divide by 0 and game over. And if you numerically approximate, you can approximate what you want, but you will never hit the 0 dot. And the I-space theory avoids this problem by not eliminating the 0 in the first place. The I-space circles have no 0 center. They have a cell-based arrangement. And the center cell has the same diameter than the cells. So you get a 6 cells around 1 cell, 7 cell minimum arrangement. And the next is 6 plus 6 is 12 plus 6 plus 1 and so on. And that is 2n plus 1 as a general. So you get x squared plus x plus 1, including the diameter, and x squared minus x plus 1 when you exclude the diameter. And that's the whole game trick. You need to be able to solve a squared equation like that, what I told you. And we don't need to study 7 years of math and physics to do that. We learned that in 8th grade in school, at least in Germany where I was raised. So it is not really complicated. And with all that simple math, I'm able to deduce 50 constants of nature exactly. Is that accidental? Maybe, but I don't think so. It is so easy because I didn't make it complicated. If you pursue the right direction, you're the lucky guy or the lucky girl or whatever. But if you go the wrong way, just because everybody else trampled it out the last 100 years and said, we just need more math, and finally we will find it, you will find nothing. More math will lead you into more problems, not more solutions. And it was, by the way, Albert Einstein who told us that a, quote, problem which has been raised by a method cannot be solved ever by the same method. It's not an exact quote, but it was basically saying that at a conference. If infinities are your problem, you cannot solve the problem with more math generating more infinities. This is what he told us. And in this case, he was completely right. And I not only believe him, I can fully support him. This is the sentence everybody should know from Einstein. And this is what most people have heard, but just don't understand what it means. It means giving up on continuum. It means giving up on infinity equations. It's giving up on the 0. Because otherwise you don't get it. And it is, we are not talking about discretizing like a chessboard's grid. We are talking about discretizing like chessboard cells. And a chessboard has 8 times 8 cells. These are 64 cells. But when you discretize it with lines, it has 1 line more on the side and on the top than you think. So it has 9 times 9 lines to discretize 8 times 8 cells. Do you see the mistake already? Chess is not played on a 9 times 9 board, it's played on an 8 times 8 board. And when you have an 8 times 8 board and constructed from singular horizontal sticks, you don't need 8 stick long sticks. You need 7 stick long sticks. Because when you place 4 7 stick long sticks in the bright 90-degree angle adjacent, then the end of one stick is giving you the 8th one. So 4 7-sized sticks gives a 8 times 8 square. This is trivial. This is trivial children mathematics, and everyone playing with Lego knows that. By the way, Lego has these sticks. Yeah, you can really buy that sticks in the lengths of 7, 6, 5, 4. But so children intuitively know that when they build their Lego models. But the mathematicians insist on starting with a 0 coordinate point in the center of 0 length, and because it's so cool doing that. No, it's not cool. It's just the first thing you learned in school. This is not at all cool. The next thing of that so-called cool thing, what you learned is you're not allowed to divide by 0. It's like, oh, really? Yeah, then why we invent the 0 when I'm not allowed to divide by it? So mathematics is a tool, a screwdriver. And without computers, it was a valuable tool. But today we have computers. And every time I program something and look into the bits and bytes of a debugger of the computer, there are no floating point numbers. They are just integer numbers in this computer, even if the computer screen tells you something else in a graphics. These are pixels on your screen. These are discrete entities you're looking on, even on a retina display on Apple, with millions of pixels on the screen that you don't see the individual pixel. But trust me, it's there. Everything on a computer is discrete. And if we live now in a computerized universe where everything is computerized or not, this is a philosophical question which I don't go into. I leave that to the individual brain deciding out as your choice, okay? But what is not your choice if zero infinity exists, because I guarantee you it doesn't. Zero and infinity is just in your brain because you learned at school and you learned wrongly. And the faster all the experts in the world forget that, the faster we progress. All string theorists, all physicists need to study IT on the lowest level in assembly language to get that understanding I have. This is the only way of getting it for free. And you have a good job, because when you have just a physicist job, you have every now and then a job and then no job, depending on the country you are in, on spendings and so on. When you have an IT, you have always a job. You can always trust me on that. So if you're not too stupid with IT, you survive. And so combining IT and physics is the most clever thing you can do for yourself and for your pupils and for the future. And with IT, you probably also understand that OpenAI and all this, what is currently hyped, is not intelligence. I don't want to hear that. OpenAI is not intelligent at all. OpenAI is stupid like hell, but it's very formal. And in Germany, we call it fleißig. So he's busy running until getting results with no ever stopping. He's not ever getting tired. He doesn't want vacation like normal people want. So this is what it does. This OpenAI is fleißig, but it doesn't make it intelligent. So that's it. That's it about from my side for this talk. I think I have to watch my own recording to make a sense of it. But as I said, Rajan, you really inspired me today with your talk, recorded or not, in the sense that relativity is not wrong. I always, when I'm in a mood of talking to a relativist, I hit him with the hard facts of ice-based theory to get in a little, let's call it soft fight or something like that. Mm-hmm. And in the end, I touched his shoulder and said, well, it's just fun. I'm just joking. Relativity is completely correct. And ice-based is also completely correct. And I can prove it. And then I look. And I said, really? How do you do that? It looks incompatible to me. I said, I know this crazy Gerd from Augsburg, you know. I said to him and went to his house to prove he's completely wrong and stop that nonsense and do ice-based instead. And when I was leaving him a day later, we didn't stop his nonsense, but was absolutely convinced his nonsense is 100% compatible to ice-based. And that is new things you detect, you don't expect. The really crazy thing happens when you get something new you don't yourself expect. This is progress. I didn't invent Gerd's model. I didn't invent ice-based in a way. I just put things together like a child. But sometimes you put things together which are much greater than the input you gave it to. You can do suddenly crazy complex things by combining two methods where each of the methods are not really powerful in its own. But combining both, you suddenly start seeing things. And this is where we need to go. Work together, not against each other. Who is the most clever in the room or anything like that? It's totally irrelevant.
Yeah, of course.
Really totally irrelevant. The egos must stay behind the results. This is the first lesson learned, especially in these days where we have leaders in the world where the egos are 1,000% in the beginning and not just 100%, where they even could be from their job position point of view. But I don't want to become political these days.
Yeah. So yeah, each person has their own piece of puzzle. Just start to put them together. So one of the things I would say, I think even the conference, if you can point out, I mean, I'll try to also point out, mathematics the following way you should, given that the physics is so and so, the mathematics is so and so. So it should come up with a qualifying statement or disclaimer, so that the mathematics doesn't override the physics, but it just helps to quantify it rather than define what physics is. Mathematics cannot define physics. It just can quantify physics. It can help physics to understand the proper thing. But the physics is the first thing, the observations.
Rajan, with quantum mechanics, it was already evil, but it was manageable still, especially with the Heisenberg method of matrices, because there were integers in there. With Schrödinger, it became more complex, but with relativity, it became too complex for the typical human. So more and more mathematicians were put into the relativistic teams to help solve the necessary calculation, and that is understandable. And when you have some 2 or 3 physicists and 200 mathematicians helping you to solve the questions of 2 physicists, it ends up as it must end up. Everything is just mathematics and no more physics, because the 2 physicists are buried by their own question to the 200 mathematicians. And in the end, the mathematicians are also not stupid. They know more about mathematics than the physicists. And this is the first fear of every physicist, that there might be people with mathematical knowledge who are better than them. But trust me when I tell you a truth. When I went to Wolfram research, I was the most happy person on the planet, because it was the few of my times in the world where I was surrounded by literally every single person in the room more clever than me. I love that, because that is rare, okay? When you're already on a quite high intelligence level and have a lot of experience at my age, you get the experience by age, you get the experience by practice, you get the experience by you creating companies in the past, by managing, raising your children. You are quite experienced. That is why older people typically don't need to have a white beard to be recognized as, wow, this person has lived a long thing. We ask him questions he might know. Yeah. So this is not the case with that wisdom style in typical theories. People fight against each other instead of looking at wisdom. And the mathematicians are the least wisdom aware persons, because their brain is so complicated wired to solve their mathematical problems that they are often can be seen as not very realistic persons, yeah? In the sense that they are, in Germany we say verkopft, so they have heads with a lot of theory in there and are not really, so hopefully the wife brings the food, otherwise the theorist would starve by hunger, yeah, because he forgets to eat. So this kind of problem. And the more in life a person is, the more I've been a consultant all my life, so I was thrown around to different companies, to different projects in a regular manner of, sometimes when I was lucky 2 years, 3 years, when I was not lucky every 3 months something else. So you come around, and when you come around, you meet a lot of new people, and that is inspiring, because everyone is thinking so much different in all companies, in large companies, in middle-sized companies, small companies. And if you add your own experience over that, you get a picture which is much more realistic of what actually happens in the world. If you have been hired by university and stay in a university degree for the rest of your life until you get retired, you make travels a lot and so on, because you might be prominent. But that doesn't mean you know a lot. All you knew was the inside of your Hörsaal or your stage where you have trained your students. Yeah? Is that a lot? I don't know. But the internet brought a lot of everything into the homes of everyone, to put it this way. Yeah? So we have different challenges with YouTube and the knowledge distribution systems of these days than traditional universities. And this is why I believe text is not only important, but is a lead way to professional science for the future, which is not marketed to death by YouTube-style methods. When we are interested in propagating knowledge to the wide audience, we might need an advertisement or two ourselves to finance our server costs or whatever. But it doesn't mean we must make a spectacular out of every clicking, interrupting every 10 minutes with an advertisement for 10 minutes or these kind of things, what YouTube is doing there. Yeah? So you interrupt the knowledge flow to yourself this way. So we should stick to the scientific way, and people forget what that means, especially in IT, by the way. IT is absolutely non-scientific these days. They are rushing around inventing new methods, new programming languages, new metaphors every day, not even every week or month, no, every day. And just because the people inventing these new methods are too lazy to read books of the past, that everything they try to invent have been invented already in the past and typically failed. And that's why it isn't there anymore. So, and this is a cycle, every 10-year repeating. A youngster comes in and says, let's do it this way. And then if I have lucky be in the project, said, no, we don't do it this way. It's a Christian, why? Yeah, because 20 years ago we did that and it failed miserably for this and this and these reasons. And then, oh, good that you tell me. Yeah. But when you don't accidentally be in the room, then they might start their project and fail a year later and drive against the hard wall. And this has also to do with experience. So you should never tell that something is impossible in your life. I hate that. Nothing is impossible. Mm-hmm. Stand up and try. And if you fall, stand up and try. If you fall, stand up and try. Because a million attempts might be the million and the ones might be the successful one. Giving up is the only thing which is crucial. If you give up, you lost. And that's it. So never give up. That's simple.
Good point. Yeah. Okay, I think we will end it there for today. And then we'll continue next week. And I'll try to record that episode 10 somewhere in between.
Yeah,
so
Christopher
there as a
separate. Even our post, so this is no problem.
Then, yeah, hopefully next week when Christopher comes, we'll put all of the things together for a conference, and then you will probably have more information about the hotel.
Yeah, I tried to do my homework. This week was too heavy to do that. I have downloaded what I have done for your information. Finally, I've downloaded the site from
that's good.
Budapest, and I had technical problems downloading some iframes from the Budapest image of the Google Maps image, and so otherwise I would have already sent you a zip file with a new HTTPS site or so. But I think within the next week I'm able to fix that.
Okay.
And I will prepare the World Style conference from IMS as a template and see what I can give you as typically PDF examples, how that should look.
Okay.
Maybe I can convert it to Word, Excel, PowerPoint as well. I'm always doing that with my Mac stuff. So, but that should be compatible to the PC stuff of others.
Oh, that'll be great. Last lot, so we'll have information about the person. So we'll touch base again next week. Thanks a lot.
Okay, thanks a lot,
all of you,
for your time.
Have a great. See you all next week.
Evening.
Thank you.
Bye.
Thank you.
Thanks.
Bye.